Old Navy clothing store wants to launch their line of clothing for women in another country. Their current clothing sizes are based on the assumption that the average height of a woman is 162 centimeters. To determine whether they can simply ship the clothes to the new country, they selected 12 women at random in the target country and determined the mean height to be 155.2 centimeters, with a standard deviation of 6.2 centimeters. Based on alpha equals 0.01, how should they proceed to enter the new market? Should they adjust their line of clothing? So this question is slightly different, but the idea is the same. We are trying to determine whether or not the mean is in fact 162 centimeters or not. So based on this information, let's first start off with our hypotheses. And pause the video and see what you come up with. So if you notice in this question, there is no direction given. So we are stating that the mean is equal to 162 centimeters, or the mean is not equal to 162 centimeters. As well, as a result, this gives us a two-tail situation. And the next step, once again, is to determine the critical values. So let's put our normal curve together, and let's show that it's two tails. And small sample size, so our critical values are labeled as t. And in this case here, our alpha is 0.01. As well, the degrees of freedom, it says 12 minus 1. 12 is the sample size, so degrees of freedom 11. So two-tail with alpha 0.01, degrees of freedom 11. Let's go to our t-table for hypothesis testing to determine what the critical values are. So once again, we're going to be using this row to determine which column to use, because it's a two-tailed test with 0.01 as the level of significance, and degrees of freedom was 11. So where those two columns intersect, where that column and row intersect, that's going to be our critical value. In this case, 3.106. So 3.106 and negative 3.106. So there's our critical values. And now we're going to determine what the test value is based on our information. So t is equal to sample mean minus the proposed mean divided by standard deviation divided by square root of sample size. Pause the video and see what you come up with. So the values I have are 155.2 minus 162, and that's divided by 6.2 divided by square root of sample size, which was 12, and this gives me a final value of negative 3.799 in the end. So according to this, then, our test value is negative 3.799, which clearly puts it in the tail area. So that's our test value. And once again, based on this, you can see that we're going to reject because it is in the critical region, the rejection region. Okay, so our decision in this case is going to be to reject H naught. Okay, so what is it that we've found? So we are going to reject this, and we're going to assume this to be true. Okay, so that would mean that our sample data indicates that the mean height is not 162 centimeters. It doesn't state that it could be more or less. It's just we know that this is not true. It's not 162 centimeters. So as a result, we would state the following. Our sample data indicates the population mean height for women in the target country is significantly different than 162 centimeters. Now, as well, how should they proceed to enter the new market? Should they adjust their line of clothing? Well, clearly they're going to have to reassess the average and customize the clothing to fit the new market. With that said, I think you should be able to handle the homework. You see, it's very straightforward, 5 steps always. And as long as we start off with a proper hypotheses, right? Once again, I sound like a broken record, but if we start off with the proper hypotheses, then the process is pretty straightforward. So just make sure that you read this question correctly and that you understand whether it's a one-tail or two-tail situation. Like I said, try the homework, and if you have any questions, make sure to reach out. Have fun.